In 2007, a radio telescope recorded a burst that lasted 5 milliseconds, yet released more energy than our Sun does in a day. Hundreds more have followed. No one knows what is producing them. This is just one of 10 mysteries science still cannot explain, from 85% of the universe remaining invisible to a 600-year-old book no human can read. It all starts with a signal no one was looking for. The first fast radio burst lay hidden in Australian telescope data for 6 years before anyone noticed. Since that discovery in 2007, astronomers have catalogued hundreds more, each a fleeting flash, lasting just milliseconds, yet powerful enough to outshine entire galaxies in radio waves. Using massive arrays like CHIME in Canada, ASCAP in Australia, and China's FAST dish, researchers have mapped these bursts across the sky, measuring how their signals stretch as they travel through cosmic gas. Some sources repeat, firing off bursts in clusters or triplets, while others remain stubbornly silent after a single event. Theories range from the magnetic tantrums of young neutron stars called magnetars to cataclysmic mergers of dense stellar remnants, to even more exotic ideas involving black holes or cosmic strings. But the patterns do not line up. Repeaters and one-offs show different energy scales, polarizations, and host galaxies. No model yet explains the full diversity of these cosmic pings. For now, the universe keeps this secret, and every new burst only deepens the puzzle. Galaxies spin with a steadiness that defies expectation. In the 1970s, Vera Rubin measured the rotation curves of spiral galaxies and found that stars far from the center move just as fast as those near the core. According to gravity's rules, outer stars should slow down unless something unseen is holding them in place. Gravitational lensing, where massive clusters bend and magnify light from distant galaxies, reveals the same invisible influence. Even the faint ripples in the cosmic microwave background, mapped by satellites like Planck, demand a hidden mass to explain the universe's structure. Astronomers call it dark matter. It outweighs everything we can see by more than 5 to 1, yet it emits no light, no heat, and no signal we can catch. For decades, physicists have tried to trap a dark matter particle. Deep underground, detectors filled with liquid xenon wait for a rare collision, but the latest runs have caught nothing. No WIMPs, no axions, not even a hint. Collider experiments, like those at CERN, have also come up empty. Some theorists suggest gravity itself might behave differently on cosmic scales, but those models struggle to fit all the evidence. Despite overwhelming astronomical proof that dark matter shapes the cosmos, the search for its true nature remains stalled. The universe's missing mass is everywhere we look, and yet, for now, it remains completely out of reach. On a summer night in 1977, a radio telescope known as Big Ear picked up something extraordinary, a single narrow-band burst at 1,420 megahertz, the frequency of neutral hydrogen. The signal lasted exactly 72 seconds, matching the time it took the telescope's beam to sweep across the sky. Its intensity was recorded as the sequence 6EQJ5, and it stood out so sharply that astronomer Jerry Eman circled it on the printout and wrote "Wow" in the margin. In the decades since, scientists have returned to that patch of sky again and again, using everything from the Green Bank and Parkes telescopes to the Allen Array and Arecibo. Every search has come up empty. No repeat, no echo, just silence. Theories have ranged from a distant alien beacon to a passing piece of space debris or an unusual natural flare, but none fit the facts. The signal's bandwidth, drift, and strength do not match known satellites or natural sources, and the original equipment was working flawlessly. For SETI researchers, the WOW signal remains the most tantalizing one-off, a whisper from the cosmos that has never been heard again, and a reminder that some mysteries resist even the most persistent pursuit. In 1953, a glass flask filled with water, methane, ammonia, and hydrogen sparked a new era in science. Stanley Miller and Harold Urey sent electric jolts through this simple mixture, simulating lightning on the early Earth. Within days, amino acids, the building blocks of life, appeared in the brownish liquid. Since then, researchers have pushed the boundaries of prebiotic chemistry, recreating volcanic pools, deep-sea vents, and even the cycles of wet and dry that ancient shorelines might have experienced. In modern labs, ribozymes, RNA molecules that can catalyze their own assembly, have been coaxed into performing simple reactions. Some experiments use minerals to trigger the formation of nucleotides, while others test whether meteorites could have delivered key ingredients from space. Yet the crucial step remains missing. No one has bridged the gap from a soup of molecules to a self-replicating system that evolves and passes on information. Theories compete. Some favor a RNA world, others a metabolism-first approach, but none can yet show how lifeless chemistry became the first living cell. The origin of life remains a riddle at the heart of biology, a reminder that even with all our technology, the spark that turned matter into something alive is still out of reach. Electrical stimulation mapping in the mid-20th century showed that sparking certain brain regions could trigger vivid memories or sensations, but no single spot revealed the source of consciousness itself. Today, neuroscientists use functional magnetic resonance imaging, EEG, and transcranial magnetic stimulation to track the difference between wakefulness, dreaming, and deep anesthesia. The Perturbational Complexity Index, or PCI, measures the brain's response to a magnetic pulse. Awake minds show high complexity, while unconscious states drop below a sharp threshold. Other markers, like the P3B component in EEG, often appear when someone is aware of a sound or image, but vanish during unresponsive states. Yet these patterns only map the shadows of consciousness, not its substance. The global neuronal workspace theory argues that consciousness arises when information is broadcast across wide brain networks. Integrated information theory tries to quantify how tightly information is woven together, but calculating its core value, phi, for a real brain remains beyond reach. Recurrent processing theory focuses on local loops in sensory areas, but struggles to explain self-awareness. Even with all these models, the leap from electrical patterns to subjective experience, the so-called hard problem, remains unsolved. Some patients in a vegetative state show brain activity that hints at hidden awareness, blurring the line between data and experience. For now, the science of consciousness is rich with measurements, but the true nature of the mind stays just out of grasp. In the early 1990s, Taos, New Mexico, became the center of a strange acoustic puzzle. Residents described a low, steady hum vibrating through homes and mesas. Acoustic field teams brought in infrasound monitors, recording occasional surges between 30 and 80 hertz. Yet only a fraction of locals could hear it, and no physical source was ever confirmed. Theories ranged from distant machinery to seismic shifts, but the Taos hum remains unresolved. partly measured and partly speculative. Out at sea, another mystery unfolded. Since 2000, hundreds of mass strandings, whales and dolphins beached in clusters, have been logged worldwide. Marine mammal responders conduct necropsies, looking for disease, toxins, or trauma. Some strandings coincide with naval sonar or brief magnetic anomalies, but many offer no clear cause. The evidence resists a single answer. In Antarctica, polar surveyors using airborne radar have mapped bright, mirror-like reflectors up to 3 kilometers beneath the ice. Some suspect thin water layers, others point to sediment or exotic ice. Drilling to these depths remains nearly impossible. Earth's signals, even with modern tools, still keep their secrets. A book bound in calfskin, filled with looping script and botanical drawings, sits under lock and key at Yale's Beinecker Library. Carbon dating places its vellum between 1404 and 1438, and every test confirms its authenticity. Sheepskin parchment, iron gall ink, pigments from alpine mines. Yet the language on its pages is unlike any seen before. Statistical analysis of the text reveals patterns found in real languages. Word frequencies loosely follow Zipf's law, and the script clusters into apparent paragraphs and sections. Despite this, not a single word has been translated, no bilingual key exists, and no known tongue matches its structure. Specialists have scanned every page for erasures or hidden layers, but high-resolution imaging shows no palimpsest. Theories abound: a lost language, a complex cipher, or an elaborate hoax, but each falls short. After a century of cryptographic effort, the Voynich manuscript remains a book that science can describe, but not yet read. In 1901, divers salvaged a corroded bronze object from a Roman shipwreck near the Greek island of Antikythera. For decades, its true nature was a mystery. Only in the 1970s did researchers recognize traces of intricate gears, hinting at a level of mechanical sophistication centuries ahead of its time. Modern breakthroughs came in 2005, when high-resolution computed tomography scans revealed hidden layers of teeth and gear trains, some as fine as a watchmaker's. Scientists reconstructed much of the device's function. It could predict eclipses, track the metonic cycle, and even model the irregular motion of the moon using a pin and slot mechanism. Tooth counts and inscriptions point to empirical corrections, evidence that its makers refined the design through observation, not just theory. Yet gaps remain. Several gears are missing or broken, and debate continues over whether it could truly model planetary motions as described in ancient texts. Even with three-dimensional models and virtual reconstructions, the full workings of the Antikythera mechanism and the knowledge behind its creation are still not fully understood. Today, scientists probe deeper than ever, but some questions still defy answers. Each unsolved mystery reminds us that our understanding is always incomplete. The unknown shapes tomorrow's discoveries, and it keeps wonder alive. Curiosity is not just for experts, it is how breakthroughs begin. What question will you help answer? Share your thoughts below.